There are many other tumors, of course, which have never been tested with vaccination because they were not immunogenic. So people thought it doesn't make any sense. But this most probably, these are those tumors which are very promising for vaccination because here there are no T cells. So you induce the T cells, and as soon as you get T cells, of course, you always get naturally the brakes turned on. But now you can give checkpoint blockers. So you will have a boost of T cells and likely you will be successful. So one example out of the melanoma tumors is the uveal melanoma, the melanoma of the eye. So the melanoma of the eye is very special. It has very few mutations and it is totally resistant to checkpoint blockade, even if you use two at the same time. So in total contrast to cutaneous melanoma, and this is most likely due to the fact that there is little spontaneous anti-tumor immunity. And that's in part due, that's at least what we think nowadays, because there are so few mutations. And mutations in part also generate new antigens that are specific for the tumor. And with the modern techniques, you can also vaccinate to these antigens, which are better than the old antigens. So in other words, one has learned that whenever you vaccinate, you also have to add checkpoint blockade, because whether T cells come up spontaneously or by vaccination, the body always counteracts to avoid autoimmunity, right? So you have to consider this experience or this insight, combine vaccination plus checkpoint. Then the second aspect is use better antigens. And there are two types of better antigens. First, the neoantigens, the neoepitopes, derived from the mutated proteins in the tumor that are very specific for the tumor. And then, that I will also mention, there is a second type, a totally new type of tumor antigens derived from proteins in the tumor that are not mutated. So the sequence is totally normal, but these are also neoepitopes because the tumors have an abnormal processing, antigen processing machinery. So if there is a protein in a tumor, as opposed to a normal cell, there are different segments of the protein put as peptides on the surface for recognition by the T cells. And this is called the abnormal ligandome. And this is a discovery by Hans-Georg Ramensey in Tübingen, already proven in malignant tumors of the blood system. And we have recently shown together that it seems that this type of antigen also exists in melanoma, particularly in uveal melanoma. This will be interesting because, you know, the problem is if you deal with a tumor which has few mutations, you will have not such a big chance to have neoepitopes on the tumor. Because if you have a mutated epitope, not all the mutated proteins give rise to peptides that fit into the HLA molecules on the surface. So if you have very many, like in cutaneous melanoma, there is a good chance. But if you have just a few mutations, the chance that you can target mutated epitopes gets less and less. So that this new class of tumor antigens that have so far been totally unknown, this kind of abnormal fingerprints on the surface of the cell composed of peptides derived from non-mutated proteins, but abnormal segments, so to speak, get more and more important, most likely. But that will turn, that has to be shown, and this will take a few years until we really know.